Our programs need to store values and they need to pull up those values later on in our program. Just like you have short-term memory inside of your mind, well, your computer also has short-term memory and it needs to be able to store values, but we as programmers also need to pull those values out of memory when we need them. Memory is just storage. So let's go ahead and take a look at creating a variable, then a constant, and then have a look at what this means for us as programmers. So what we need to first of all do is to create a variable, we use the var keyword. Now when you do this, you're creating a box. Think of it like you're creating a box and the box needs a name because your program can contain thousands of boxes that contain all different values. And you need to be able to identify what is inside of that box. So let's go ahead and create a variable called name. So this box now has a name. Now please don't make this a string because this is not actually defined as a string. It's actually defined as a symbol. It's a memory address. Think of it like this. Your house has an address. The address isn't the house, but it is a way to target your house so the postman can find you and post a letter through. Well, likewise, we want to find stuff in memory. So this time what we want to do is we want to create a box and we want to give it an alias name so that then we can target this in memory. We can find it, we can point to it in memory. So we're going to create a variable called name and then we're going to use the equal sign. Now the equal sign is the assignment operator. It's a command to the JIT compiler and we'll talk more about operators later. But this command is going to say take whatever is to the right of this operator and assign it to the box. So I'm going to say go ahead and define the string Lawrence and then also we end with a semicolon. And think of the semicolons as the full stop to your sentences, just like in the English language. When you write a sentence and you're finished, you write a full stop. That's what your semicolons are there for, to say this statement, this command that I'm giving to the JIT compiler is finished. So that is a command to the JIT compiler to create a variable, to create a new box, label that box so that we can understand what that box contains. We have a general idea, so it's nice and easy for us to address that box, target it, and then we want to assign the value to the right of it. Now this could be a string, a number, a boolean. It could even be null or undefined. It could be anything that you would like it to be, an object or an array. But it needs to be one value that is then going to be assigned to the box. It's going to be placed inside of it. So we're going to take this string and place it inside of this box, and there we go. And then when I put in the name, you'll see I say name. So I've focused on this value stored in memory, and it's pulled out that value, Lawrence. And that's nice and easy. And as I said, your program can contain thousands and thousands of boxes, so we need to use our names wisely. Now, when naming your variables, please don't start with numbers or even a capital letter or, any sort of special character. But what you can do is, you can have divides in here and so forth. But try to keep it as simple as possible when creating your variable names, and never put in spaces. That's not allowed, and never define a name as a string. So that is how it works. It's simply an addressing system. Now, being a variable, well, you know what variableness is. It means it changes. It's variable. It changes in value. So with this box, I can actually assign a new value, such as Turton, and end with a semicolon because I've completed that statement now, that command. And what it will do is it will delete out the old value that was stored in that box and it will assign a new value, Turton. And now, when I type it in, you'll see it gives me Turton until, let's say, my program later on changes it to something else, like so. And then I can type in name and it will keep giving me that name until it's changed at a later date. That's a variable. Now, with variables, you can also create a blank variable as well. You don't need to assign a value straight away. You can actually create a box waiting for a value to be stored. Now, when I do this, you'll notice it returns undefined. It may return null. Don't forget, null and undefined are primitive types. They are values to say there is no value. It's void. It's hollow. It's waiting for a value to be assigned, in other words. It's just an empty box. It's just a way of telling you there's an empty box. So if I now type in blank, I'm just going to keep getting undefined until I actually change the value. So let's go with blank and then let's say new value. And what that will do is it will take out the undefined or null value primitive and it will put in a string, for example, or an object or an array, which we'll talk about later on. But basically what you need to understand is variables and constants are just ways of fetching data out of memory so that we don't have to type in really complicated numbers to try and find data in memory. We can just type in a nice, easy name. Now, also, JavaScript is a loosely typed language. And what do I mean by that? Well, it's loose on its data types. So, for example, you could have a variable. Again, we have the variable blank. And blank contains a string data type, like so. So we can reassign a string. However, in some programming languages, it will only allow you to assign a certain data type. Once you've created that variable and you've assigned a data type such as string, you can only assign a string value to that variable. Whereas in JavaScript, that doesn't happen. It's loosely typed. It's loosely typed data. So you can change the data type, such as instead of being a string, it could be a number, or instead of a number, it could be a Boolean, and so forth. And instead of that, you could have an object, or instead of that, you could have an array, and we'll talk more about this later on. And so what that allows you to do is what we're doing here is we're assigning different data types from string, number, Boolean, object, and array to the same variable. It's a loosely data typed language. Now, the other type of box is a constant. So you've got variables that change in value. Well, you know something is constant, it doesn't change. It's the same today, yesterday, and forever. So a constant is constant throughout the lifetime or the execution of the program. Once you've defined a constant and your program is executing, the constant always stays the same. So it's a constant, and then you need to define a symbol name, an address name. So I'll just say last name. And with this last name constant, I'm going to say Turton. Now, you cannot, under any circumstances, create a constant without assigning a value. Before, we created a variable and we didn't assign a value. That's because we can add a value later on. But with a constant, you can't add a value later on. So when you create a constant and you create the name of the constant, the symbol, you can't then later on assign a value. So your constant needs to have that value assigned straight away. So you know what the value is. You're more consistent in your thinking. You know it's going to contain that value, and that's what the value is, and it's never going to change throughout the lifetime of your program. And that's good for security reasons, so nothing else can change that part of your application, that memory address. So we have a constant called last name, and we're going to assign the value Turton into that box. And then you'll see last name. And there you go, it has the value of Turton, and I can keep typing up. But if I try to assign a new value like a variable, well, don't forget, it's look but don't touch. It's constant in nature. So if I try to assign a new name like Lawrence, it'll say, I'm sorry, what you're trying to do is you are trying to assign a value to a constant. And you cannot do that. Once you have a value stored within it, it doesn't change. It's still a memory address, it's still a box, it's still a pointer, but this box is sealed. It won't let you open it back up again and take out the value and put in a new value. If you want to do that, you need a variable. And if you don't want to do that, if you know that you're going to set the value and that's it, then you use a constant. That will help your application be a bit more robust. Now, what you have to think of is that last name is a symbol. And also you have the other one, which was name. These are symbols. And in fact, if I take a look at the window object and I expand the window object, you have a whole host of names right here. These are ways for us to access either a function or a value. So we need an ability, the programming language needs an ability to store all of this together. And what it's actually called is a symbols table. A symbols table is like a database, and it stores all of these symbols, these names that allow us to access values. You can also think of a symbols table as a giant warehouse that contains all of these boxes, and all of these boxes have got names on them, and then we can go into the warehouse and we can find the box with the right name. And think of the window object as this giant warehouse, this warehouse where we roll up the shutters. Let's roll up the shutters and let's enter into this giant warehouse with boxes full of different names. And you take a look at all these different symbol names that you can see here in purple. But then also, if you keep scrolling down and you keep scrolling down, eventually you will find the symbol that you created named, there's my box. I can find my box in this gigantic warehouse full of boxes because it has a very specific name. It has a unique name right here, and there is my value. And that's what it's doing, is it's looking through this gigantic warehouse, it's finding that box, pulling that box out, opening the box up, and giving you the value back. And then you can do what you need to do from there. So this is actually what is the symbols table. It is, in fact, just a database, a warehouse. And we have boxes, which are variables and constants. Your variables vary in value, your constants stay the same in value once assigned, and of course variables can have different data types assigned to them. They're loosely typed, so you can have a string, a number, and so forth assigned to a variable, assigned to that box. It doesn't have to be of the same data type.